friends, myself Shweta Ganvi. Today we discuss the topic of soil moisture measurement and its estimation. So what is soil moisture? Soil moisture is the water which is held in between the space of soil particles. Then, so why it is necessary or what is the importance of soil moisture estimation? So for timely scheduling of irrigation and for estimating the amount of water which is applied in each irrigation, means when we have to irrigate the crop, to determine their scheduling of irrigation and at one irrigation or each irrigation in which quantity of water we have to apply to particular crop, that we have to determine by estimation of soil moisture from the soil. So this is important for that. What is the scheduling of irrigation? So scheduling of irrigation means when to irrigate and how much to irrigate. That is scheduling of irrigation. So it is important to scheduling of irrigation and which quantity of or amount of water we can be applied in each irrigation. Then we study about objects in measuring of soil moisture. So what is this object? First we see about to find out availability of soil water. Find out availability of soil water means which quantity of water is available in the soil for the growth of the plant we can be estimate. Then second one is to work out the available storage capacity of the soil, means particular soil have storage capacity according to texture. Every soil has different types of storage capacity, so we have to work out that available storage capacity. Then third one is to determine optimum soil water regimes and depletion pattern and conservative use. So for to determine the soil water regimes, particular soil water regimes and conservative use of crop. So what is the conservative use? Conservative use means the amount of water which is utilized by the plant for its metabolic process. That means the conservative use of water. Then fourth one is to find out suitable time of irrigation, means for to irrigate the particular crop, which time is suitable and when to irrigate, that can be determined by measuring the soil moisture. Then fifth one is to calculate the amount of irrigation water for recharge the root zone, means near the root zone of the crop which quantity or which amount of water is required for fully submerged condition or fully fill the pore space of the soil. That's why it is necessary to measure the soil moisture. Then we see here about methods of soil moisture measurement. So there are two types of methods. One is direct method and indirect method. So indirect method we study about gravimetric and volumetric method, then methyl alcohol method, then spirit burning method, sulfuric acid method and thermocouple psychrometer. And indirect method, that we have to use various instruments, that is first is tensiometer, then electrical bicos or gypsum block method, then pressure plate apparatus, and fourth one is Neutron moisture meter. These are the methods of estimation of or measurement of soil moisture, direct method and indirect method. But what is the difference between indirect method and indirect method? Indirect method measure the soil moisture on the basis of wetness or wetness in the soil. But in indirect method we measure the water potential of the soil, water potential or tension. So tension means the tenacity with which the water is held by the soil at various conditions, means at field capacity, at permanent melting point, at a gravitational water. These are the in soil moisture constants. We have to see about these types of soil moisture can be held in the soil. But this water can be held in the soil at various moisture tension, means field capacity is held at 1/3 atmospheric tension, permanent melting point is held at 15 bar. So these are the soil moisture tension, means the tenacity with which the water is held in the soil. So indirect method measure the water potential or tension in the soil, and direct method measure the moisture content on the wetness in the soil. So and direct method it is can be carried out in a laboratory condition, and indirect method we can be carry out directly in the field condition. Therefore this method is a in situ method of soil moisture measurement. Then see about indirect method. First is direct method, we see gravimetric method. In gravimetric method, first we have to take a soil sample, about 100 gram of soil sample in aluminum moisture box by a agar. Then airtight aluminum moisture box, take that soil sample, then weight that soil sample. So weight for soil sample, that is WS1. We as a WS1. Then dry this soil sample at 105 degree Celsius for 24 hours in a oven. After that, then drying sample can be 24 hours. After drying, we have to take the sample, remove from the oven and cool at room temperature. Then this sample can again weight, that is WS2. WS1, first is wet soil sample weight, and second one is dried sample weight is a WS2. Then differentiate the weight between these two, wet sample and dry sample. We can be easily calculate the soil moisture on the basis of wetness or by the gravimetric method. So we can be says grammatically, this is the procedure of collection of soil sample. First is A, that is take a soil sample from desired depth in a field. Then this take soil sample with help of spatula also. Then it is kept in a airtight aluminum moisture box. So mathematically we can be, it is write as a soil moisture on the weight basis, weight of wet sample and minus weight of dry sample divided by dry sample multiplied by 100, means WS1 minus WS2 divided by WS2 multiplied by 100, that is the moisture percent on the basis of weight basis. So this is the method of gravimetric method. Then we see about volumetric method. In volumetric method and gravimetric method, the procedure of the drying sample is same in oven. But what is the difference is, in this method we have to collect the soil sample, then known volume, collect the soil sample from the field by tube agar or core sampler with a known volume. It adds the volume only, and that amount of water that present in the soil sample we can be estimated by drying it in a oven. So same procedure as a in a gravimetric method, take a soil sample, then airtight condition, it is dry in oven for 105 degrees Celsius temperature for 24 hours. After remove the sample from oven also, and take a difference between these two. So but we have to take soil sample, so we have to take soil sample with known volume and calculate moisture by formula. This formula mathematically we here write as so equal to WS1 minus WS2 divided by dW, means density of water, multiplied by VS1, means volume of known volume of soil sample, multiplied by 100. So WS1 means what? It is the wet soil sample weight. Then WS2 means that is the weight of dried soil sample, and dW means it is the density of water, because known volume soil sample, therefore addition of density of water, and VS1 there is a volume of soil sample multiplied by 100. We can mathematically write as a in this way, and this method is useful in a laboratory condition. It is simple and it gives the value of accurate value or accurate measurement, and therefore this method is used for experimental purpose. Then next method, this is the core sampler and tube agar for collect the soil sample, we see here. Then Third method one is methyl alcohol method. In methyl alcohol method, this is the simple method. In this, mix the soil sample with known volume of alcohol, and after that, after mixing the alcohol, there is a change in specific gravity of alcohol, and that change in specific gravity of alcohol we can measure by the hydrometer. This is the in method of methyl alcohol method. Then calcium carbide method. Fourth one is indirect method, calcium carbide method. So in calcium carbide method, we have to mix the soil sample with known amount of calcium carbide, and after mixing the calcium carbide in soil sample, that calcium carbide is react with the water, and after reaction it remove in the form of acetylene gas. Means first soil sample mixed with calcium carbide, then it after mixing reacts with water, and that is remove calcium carbide in the form of acetylene gas, and this can be also moisture determined by difference in weight in both in wet soil sample, and after remove the calcium carbide mix and remove the calcium carbide in the form of acetylene gas. These two differentiate the weight, and we can estimate the soil moisture. Then fifth one method is spirit burning method. It is the in spirit burning method, this is also a simple method. This method is firstly we can propose this method, and in this method there is a name of burning, so we can be initiate or burn the soil sample on the spiritly. Then therefore what will be happen, there is a dried the soil sample, and this method can be continue till up to weight is constant weight is obtained, and therefore this continuous process required the about 10 minutes. So we can be obtain the soil moisture, and therefore what will be happen, due to burning method of soil sample, there is a chance to burn the organic matter in the soil, and therefore this method is situated is laboratory, and electricity are not available, that type of facility are not available. In that situation, this method we can be using spirit burning method. Means first to soil sample is burned or initiate with the spirit, and therefore sample will be dry, and we can the weight we can obtain the weight of the soil sample. This is the then sixth one is infrared balance method. This is direct method of infrared balance method, and this method is for drying the sample quickly. In this method we can sample can be dry quickly, and in this method we use the red lamp of infrared lamp of 250 watt. 250 watt red lamp we can be used, and therefore due to that light emissions or radiation which are emitted, that lamp can be on the soil sample, and therefore what will be happen, the water vapor saturated on the surrounding atmosphere. Means if we have collect the soil sample in moisture box or any container, that in that container after drying, that due to that radiations, water vapor can be saturated that in container in a drying chamber. Then what will be happen, the water vapor is continuously replaced by fresh air into drying air, and therefore the rapid drying of soil sample, we can be rapidly drying the soil sample by infrared balance method. These are the direct method of soil sample measuring. Then we see about indirect method. This method can be used in a in situ condition, means in a field condition. So we have to use the indirect method with instrument, that tensiometer, gypsum block, like that. So first is gypsum block method. In gypsum block method, gypsum block is made up of plaster of Paris. Gypsum block is a gypsum block or plaster of Paris resistance block, and that is used for measure the soil moisture in situ condition, means in a field condition. So this is gypsum block first invented by Bicos and Meek in 1940. So these blocks are generally rectangular in shape. Various shape can be used of gypsum block, but this can be generally made up of rectangular shape, and after the blocks are made up of various materials like gypsum, nylon, fiberglass, plaster of Paris, or combination of these. So it can be, and these blocks are works on the principle of conductance of electricity, means on the basis of electricity conductance it can be worked. And in these blocks there are two electrodes are placed in parallel to each other. In soil surface, two electrodes are placed in parallel to each other in soil medium, and current is passed in between these two electrodes. After that, when block is wet condition, then conductivity is high and resistance is low. So when there is a so when this current is passed, so resistance, when block is wet, the conductivity is high and resistance is low. So after current is passing, there is a resistance of flow of electricity is proportional to the moisture content in the medium, means that moisture content in the medium is directly proportional, and therefore when the block is wet, conductivity is high and resistance is low. So the generally these blocks read about 400 to 600 ohm resistance at the field capacity and 50,000 to 75,000 at ohms at wilting point. Then these readings are taken at portable Wheatstone bridge, which is operated by a dry seal. When we place the gypsum block on the soil, then we have to take one care that that block must be in a close in contact with the soil surface, undisturbed soil surface. Therefore, what will be happen? The correct reading can be obtained. Then limitations of gypsum block. What is the limitation for gypsum block for use of this? First is, while placing the gypsum block in soil, their care should be taken. The block must have close in contact with undisturbed. We have earlier see here. Then after placing the blocks, get wetted with the soil moisture. It can be wet after placing in soil sample due to moisture, and there due to capillary movement it can be wet. And pure gypsum block sets in 30 minutes. It can be placed in a 30 minute in the medium. Then third one is, the gypsum block is sensitive to soil moisture from 1.0 atmosphere tension to 20.0 atmosphere. It can be sensitive at moisture tension 1 to 20 atmospheric tension. Then last is how gypsum blocks are not reliable in wet soil. It cannot be in a wet soil, it cannot be reliable or it properly work. Then this is the view of gypsum block. This one you can see these electrodes parallel to each other. We have in procedure these electrodes are in medium taken parallel to each other, and this can be meter. It gives the reading. Then second is, we see about tensiometer. So tensiometer is also called as a aerometer, and it is popular method of tensiometer soil moisture estimation in situ soil moisture. So it is also called as a aerometer. And tensiometer measures soil moisture tension, means the tenacity with which water is held by the soil. And tensiometer designed by Richards and Gardner in 1936. This is Richards and Gardner in 1936. So what is the structure of tensiometer? How is structure? We can see here from the diagrams of tensiometer. So it consists of long porous clay or ceramic cup, means that one. It is the long porous or ceramic clay cup. It is in length of 7.5 centimeter long. This one is porous ceramic cup, and this is hollow metallic tube. This one is hollow metallic tube. It is made up. Then vacuum gauge. This one is a vacuum gauge. Give the reading. And cap for closer. This is the cap for closer. So then how to work the tensiometer in soil condition. So first is, at the time of installation, this system is filled with water. Means this porous cup, from the side of porous cup, tensiometer is installed in the soil surface. Then after that, this is filled with the water from the opening of the top or cap. By opening the cap, we add the water in the tube. Then after that, rubber cork can be cover the rubber cork when it installed in the soil. Then water from the porous cup moves out in dry soil. Slowly, one by one, porous cup, from the porous cup water can be moved in a dry soil, and therefore after it creates a vacuum in the tube. Therefore the material of porous cup can be made up from the ceramic clay, or that is made up from ceramic clay, because the water from the tube, it can be moved in the soil surface. So, and due to it move from the soil surface, there is a vacuum is created in the tube, and that vacuum can be measured directly. This vacuum gauge is measured directly the vacuum which is created in the tube, and then when desired tension is reached, the soil is irrigated. So tensiometer works satisfactorily up to 0.85 atmospheric tension. The working of tensiometer. Then what is the merits of tensiometer? Tensiometer is very simple, and therefore it is estimated in soil moisture in situ condition. This is the important thing. It is working in situ condition. Then it is useful for scheduling of irrigation of crop. In crop scheduling, it is useful to scheduling of irrigation crop, and therefore it requires a frequent irrigation at low tension. Then third one is, when it is best situated to used in sandy soil. It can be properly work in the sandy soil, because in clay soil there is a property swell and shrink. Therefore in wet soil, the clay soil is a swell and shrink, and therefore is a crackness, and it cannot be worked properly in the clay soil. So in sandy soil it can be worked properly. Then limitations, we can see about limitations of tensiometer. So it works up to 0.85 atmospheric tension. Then it is less situated to use in fine texture soil. It is not useful in fine texture soil. Mostly it is used in a sandy soil. Then third method is indirect method, neutron moisture meter. In this method, the soil moisture can be estimated quickly and continuously with neutron moisture meter without disturbing soil. Means there is no disturbance in soil during the soil moisture estimation, and this method is a quickly method to estimate. Then this method is based on measurement of, on the basis of number of hydrogen atoms that are present in unit volume of soil. Unit volume of soil, how much number of hydrogen atoms are present, on that base it can be work, or it can be measure the soil moisture. So we can see about view of neutron moisture meter. This is installed in the soil surface. So this is view of neutron moisture meter. Then what is the working of neutron moisture meter? So it works in the, it contains probe. Probe contains fast neutron source, and which may be mixture of radium and beryllium. That probe and rate meter. So probe may contain fast neutron source, and which may be mixture of radium and beryllium, and that assist tube are aluminum tube of 50 to 100 centimeter length, and these are tube are placed in the field where moisture to be estimated. When we have to estimate moisture, there is a place. Then neutron probe is lower probe into assess tube inserted vertically. It can be inserted vertically in the soil at a desired depth, and therefore fast neutrons are released from the probe. After installation, or after inserted in the soil, it can be probes can be from the probe, it released from the probe neutrons. Then that neutrons which scattered into the soil. After release, it can be scattered in the soil, and when neutrons encountered nuclei of hydrogen atom of water, their speed is reduced. Then rate of water count number of slow neutrons. That rate of water count the rate meter, that counts the number of slow neutron, and which is directly proportional to the water molecules. Then merits. What is the merits of neutron moisture meter? It is rapid method of measurement of soil moisture in situ. In situ measurement, it is rapid method. Then it measures amount of water from large volume of soil. Large volume of soil, can be amount of water can be estimated. Then it can be used in salt containing soil. It can be satisfactorily work also in a salty soil also. Then limitations. So limitations, it is expensive and moisture content from shallow top layer cannot be estimated. So this method is expensive method, and therefore is also cannot be working and estimated in shallow top. Then next limitation is the fast neutron are also slowed down by other source of hydrogen. Means other organic matters or clay matters are present in the soil, then there is a neutrons are slowly slowed down. Then third limitations is improper use of meter can be hazardous due to radiation. So due to radiation, if there is a no proper use, then there is a hazardous. Then it next is it assess tube interfere with the field operation. When we install the tube that interfere the field operation, these are the limitations of neutron moisture meter. Then fourth method is pressure membrane apparatus. So pressure membrane apparatus, it is this method is used for measurement of soil moisture potential, and this method is also consists ceramic pressure plate. So next we see about working, how to work the pressure plate membrane. First is porous plate are first saturated. So this method we use the ceramic pressure plate, so that porous plate are first saturated by water and the soil is placed on that plate. Then soil sample are also saturated and plates are transferred to metallic chamber. After saturation of soil sample, that becomes transferred to metallic chamber, and then chamber is close to airtight and pressure is applied by the compressor. Means first pressure take a soil sample and saturated plate, then saturate the soil sample, and then it transfer in a metallic chamber, and that metallic chamber we kept in a airtight container, and then after apply the pressure by compressor. Then what would happen? The water start to flow out from the saturated soil sample. When we apply the pressure by compressor, it become flow out from the saturated soil sample, and the soil sample are taken out and oven dry for determining the moisture content on weight basis or volume basis. Means when soil sample after it remove or flow out, then it becomes soil sample be dry in a oven when you see as a gravimetric method on the weight basis and volume basis. Then merits of pressure plate membrane apparatus. So what is this? It covers the wide range of soil water, and limitations, that is it requires a sample to be brought to laboratory. Means all this up to we see so from various methods by gypsum block, tensiometer, neutron moisture meter. In this we can measure the moisture in situ condition, means in field condition, but this in indirect method we measure the soil moisture from in a laboratory condition. So then it requires a long time for its equilibrium. For measurement it requires a long time. So we can see about view of pressure plate membrane apparatus. This one is this red chamber that is kept in soil sample. It is internal view, that is pressure source, that is pressure plate where soil sample is kept, and after kept is it becomes wet, and after then apply the pressure and flow out of water. The last one is measurement of soil moisture method, feel and appearance method. So this method is popular in, and it is simple method because our farmers can easily use this method. Easily use means most of the farmers use this method nowadays also. Feel and appearance means, and this is a practical method that estimate the soil moisture content. that is obtained by fill and appearance method of soil sample, which is taken in a desired depth. From desired depth we have to take on the soil sample, and the soil sample is squeezed by our hands or our fingers, and fill and appearance are taken into consideration. When in fingers it becomes squeezed, when it is becomes wet, then we consider the soil moisture. In this method there is a actual moisture content we cannot be determined as the as a gypsum block tensiometer by this instrument. So this is methods of soil moisture estimation. Thank you.